Yeah, welcome back, friends. Now we are uploading Rust Programming Inside Out, Chapter 6 of 41 Plus. Chapter 6 of 41 Plus. So far we have uploaded up to Chapter 5 of 41 Plus. Today we are uploading Rust Programming Inside Out, Chapter 6 of 41 Plus. In this video, we are describing the scalar types available in the Rust language. They are nothing but the integers, floating point numbers, then the Booleans, and finally the characters. We describe the integer types in great detail first. Each will be explained later, but first we are describing integer type in detail. And we are giving a detailed example on the integer type. Now, please, we will now go into the video. Fine.
Yeah, scalar types. Scalar types. A scalar type represents a single value. A scalar type represents a single value. Full stop. For example, see 10, comma 3.14, comma C. Look, C within single quote, etc. Full stop. Rust has four primary scalar types, namely Rust has four primary scalar types, namely integer, one integer, two floating point, three booleans and characters. Booleans and characters. We will learn about each type in our subsequent sections. We will discuss about all these things in our subsequent sections. Fine. Yeah, integer. We are discussing integers. Look. An integer is a number without a fractional component. We know that an integer is a number without a fractional component. Full stop. Simply put, comma, the integer data type is used to represent whole numbers. To represent whole numbers. Full stop. Integers can be further classified as signed and unsigned. Signed and unsigned. Full stop. Signed integers can store both negative and positive values. Unsigned integers can only store positive values. Full stop. A detailed description of integer types was already given in earlier discussions. Fine. The size of an integer can also be arc. Be an arc, ARCH, arc, full stop. This means the size of the data type will be derived from the architecture of the machine. From the architecture of the machine, full stop. An integer, the size of which is arc, will be 32 bits on an x86 machine and 64 bits on an x64 machine, full stop. An arc integer is primarily used when indexing some sort of collection. A simple example follows. We are now discussing a simple example. Fine.
Yeah, an example on integers. This is an example on integers. Fine. See, fn main function. Fn for function. Function, main function. So everything is in lowercase. On the same line, we are keeping the opening brace. Next, we are declaring a series of integer variables. See, let result is equal to 10 semicolon. Let result, the variable name is result, is equal to 10 semicolon. I32 by default. Because it's I32 by default, we have not mentioned explicitly the type. Otherwise, we normally mention the type explicitly. After the variable name, we are keeping a colon and then we are keeping I32 or U32 or whatever. Here, since it is by default I32, we have not mentioned the type. Okay, fine. Next. Let age colon U32 is equal to 20. We have clearly mentioned U32. So let age colon U32 is equal to 20 semicolon. Again, next. Let sum colon I32 is equal to 5 minus 15 semicolon. It's a negative number. Look. 5 minus 15, 1 5. So the result it will be minus 10, minus 10. The value will be minus 10. Since it's a I32, signed integer can store both negative and positive numbers. No problem. This is signed integer. It can store both negative and positive numbers. Fine. Next. Let mark colon I size is equal to 10 semicolon. Again, let count colon U size is equal to 30 semicolon. I size and U size. So here I have mentioned, see, I size. U size cannot be negative. U size cannot be negative and is generally used for memory addresses, positions, comma, indices, comma, lengths, etc. Whereas I size can be negative. I size can be negative and is generally used for offsets to addresses, comma, positions, comma, indices, comma, lengths, etc. Okay, fine. So there is I size as well as U size. Okay. So let mark colon I size is equal to 10 semicolon. Let count colon U size is equal to 30 semicolon. Fine. So a series of variables we have mentioned. From all are integer variable. All are integer variable. Fine. All are integer variables. Then look, println macro. Println macro. We are calling println macro in bracket within double quote. Result value is this placeholder. The whole thing is within double quote, comma, result. Close the bracket, semicolon. See, result value is, this is a pair of curly, empty curly brackets or braces. So that is all. This result value is this pair of curly brackets. We call it as placeholder. So that whole thing is within double quote, comma, result. The content of result will come and sit in the empty braces. Fine. Close the bracket, semicolon. Fine. Again, println macro in bracket. Sum is the placeholder again and age is placeholder. That much is within double quote. See, sum is placeholder and age is placeholder. The whole thing is within double quote, comma, sum, comma, age. Close the bracket, semicolon. The content of sum will come in the first placeholder and the content of age will come in the second placeholder. You know all those things. Then again, println macro in bracket within double quote. Mark is this placeholder and count is again placeholder. The whole thing is within double quote, comma, mark, comma, count. Close the bracket, semicolon. That's it. So the content of mark will come and sit in the first placeholder. The content of count will come and sit in the second placeholder. The placeholder is nothing but a pair of braces or a pair of curly brackets, empty curly brackets. Okay, you know all these things very well. Close the bracket, semicolon. Next, see, this is the closing brace. This is actually the opening brace for the main and this is the closing brace. Okay, it's all very simple program. Some small comments I have put. The above code will return a compilation error if you replace the value of age with a floating point. It's obvious. The age is actually you unsigned int. So if you are going to replace the value of age with a floating point, this will create a compilation error because it is clearly mentioned as U32. Fine. All are very simple. Okay, fine. So you can check the result. Result value is 10. It's actually 10. Sum is minus 10 and age is 20. Again, the output, see, sum is minus 10. I told you it's a negative value. There is, sum is 5 minus 15. It's a negative, so it's negative. Sum is minus 10 and age is 20. Finally, mark is 10 and count is 30. Mark is 10 and count is 30. Okay. Everything is very simple, absolutely simple a program. Yeah, just if you want, we will again run, we will check. Then we will see, we can click this. Yeah, result value is 10, sum is minus 10 and age is 20, mark is 10 and count is 35. I think it's very simple a program. Now we will just come to it. We will close it.